Hey, welcome back, everybody. This is Mr. Schneeline. This is going to be a video covering the Unit 1.2 notes, measurement, and SI units for physical science. In this video, we're going to quickly go through the lecture notes in case you missed them, and if there's any details that you want me to explore on that may have not gone into in class. And also, we're going to go into check your understandings. So if you're just here to see the answers for the check your understandings, the timestamps are in the description of this video on YouTube. So just use those timestamps, click on them, go to those particular check your understanding so you can see how it is that I came up with the answers that I did. Okay, so the notes look kind of daunting. There's a lot of slides, but there's not a whole lot of material in them that we really have to cover because for the most part, this is stuff you've heard before. You've had a little bit of experience before, and we're going to just kind of really solidify that information, really solidify that knowledge. So let's kind of get into it real quick. So the first slide, of course, is going to be our student learning objectives. So hopefully by the end of this little unit section, which we're going to be finishing up here by Friday, this is what I hope that you walk away with. I hope you can identify the metric standard units using scientific measurements, identify the units for and define the terms mass, volume, and length, and then you can convert metric units to other metric units using the ladder method. Okay, so let's keep going. So just like last time, let's start off with a question. So take a second here. You can pause the video, write this in your own words. What is the reason for scientists to use the scientific method? So pause the video, try to come up with the best answer here. Okay, so the answers for this one, or the number of answers are found in the speaker notes here. So answers like it's a universal language of measurement that isn't stopped by language barriers. It's easy to use. It's a universal standard, more or less. That's why scientists use it. Okay. Doesn't make sense to have a unit of measurement that is used in Spain in a test, and then in the US, we use something completely different, which we do, but scientists don't. It'd be weird if we both had completely two different sets of measurements, because then how is it that we can replicate it? How can we replicate it if we don't have the same units of measurement? So it's a universal language of measurement. It was created by the French. And we'll get in, that gets into a little bit why it is that we call it the SI units. Okay, so they use these measurements. It stands for International System of Units. That's what the SI stands for. Now, why is it the S and then the I? It's because it's I believe in the way they say it in French, it's like Sistema International, more or less. It's that's how they say it. It just stuck, and so that's how we see it today. So as I mentioned, it's a universal method of measurement so that language isn't a barrier and it's super easy to convert units. And I'm sure you've heard metric system and SI units. They're pretty much the same thing. The metric system is, we use SI units when we're using the metric system, if that makes sense. If I say, well, what's this unit measurement in the metric system? It's the same thing as asking, what are these SI units for this measurement? It's the same question. Okay, so don't be confused between metric and SI units. They are the same thing. Okay, so the three that we're really going to cover, the three main ones are mass, length, and volume. Now there are others, like there's density, there's lumens, there's all kinds of other. They're in that wheel on the slide before. But we're going to focus on these main three because these main three are the foundations of understanding SI units, metric units, and better understanding how it is that we convert. Okay, so mass, we have to know what mass is. Well, mass is the amount of matter in an object. Now, we should know this. We should remember this from middle school, okay, that this is what mass is, okay? And scientists use grams to measure mass, okay, grams to measure mass. It isn't affected by gravity. So as you see in the little picture to the left, you see how the mass of this individual on the moon is exactly the same as on the Earth. It's just the weight's different because weight is a measurement of force due to gravity, which we'll get into, further in the year. Okay, it's very different than weight. And as an example, it's like it'd be saying like The Rock, Dwayne "The Rock" Johnson has a mass of 118 kilograms. Okay, so length, Clearly, it's a measurement of size and distance. And scientists use meters to measure length. They use meters to measure length. Okay. So an example of using that would be the Willis Tower is 443 meters tall. Okay. That'd be an example of using meters. So we've got mass, we've got length, and then we've got volume. And volume is the amount of space an object takes up. Okay. How much matter is found within this particular space? Okay. Scientists use liters to measure volume. So they use liters to measure volume. So as an example, an Olympic pool has a volume of 2.5 million liters. That's a whole lot of gallons of water, man. That's a whole lot of little bottles of water. Okay. Now, when we talk about the metric system, we use basic units, and that's what we just saw on the previous slide. So grams, liters, and meters are all basic units for mass, length, and volume. So mass, remember, has grams. Length, we measure in meters. Volume, we measure in liters. Okay. So grams, meters, liters are our basic units. And each of these have their own abbreviation. So grams is associated with a lowercase g. Meters is a lowercase m. And liters is an uppercase L. Okay. So again, remember, I'm going pretty quick through this because it's not very new stuff. It shouldn't be new stuff. So scientists use the basic units, but also need a way to measure things that are either crazy big or super small. Or if you're going from something that's crazy big to something super small or vice versa, and to do that without filling a whole page with numbers and just get completely lost in measurements or even be able to measure them at all. So scientists use prefixes to increase or decrease the range of values. Okay. So remember, a prefix is a word, letter, or number placed before another word, letter, or number. Okay. Remember, you've got pre in the word prefix. There is a prefix in the word prefix. It's pre. Okay. So metric prefixes attached to the beginning of a basic unit of measurement in the metric system. So remember, from the literally just the last slide, our basic units are grams, liters, and meters. Okay. So we'll take those guys. Those are our root basic units. And we're going to put prefixes in front of them to tell the reader the range of values that this is set in. Okay. So that gets into the ladder method. So metric system uses a range of tens for each of their prefixes, as shown in the next few slides. So if you ever forget which is higher than the other, you can at least remember that you just have to move the decimal in a particular direction to change the value. Okay. That's unlike standard units, because if you've got, as an example, 3 feet, well, how many inches are in a feet? Well, there's 12 inches in a foot, so you have to divide 36 by 12 to find out how many. You have to multiply it by. Oh my goodness! If you want to know how many inches are in 3 feet, you have to multiply 3 by 12. Okay, because for every foot, which there are 3, there's 12 inches. So 12 times 3 is. Okay, here in the metric system, we don't do that. In the metric system, it's all by tens, which we're going to see in just a little bit. Okay, so a decimal point, remember this is the dot placed after a figure representing units in a decimal fraction. Okay, that's going to be crucial here. So this is going to be the first check your understanding, is we're going to remember how it is that we find the decimal point, even if we're not really given one. Okay, oh, I guess it's in the next few slides. My apologies. So here are our metric prefix ranges. So kilo is within the 1,000 range. Hecto is in our 100 value range. Deca is 10. And then we skip our basic unit, and then we go down to deci, which is a tenth. Centi, which is 100th. And then milli, which is 1,000th. Okay. Now, there are others that go above kilo. There are others that go below milli, but we're going to just focus on these 6. Plus our basic units, which our basic units are more or less just 1, okay? So these prefixes also have their own abbreviation. So there's kilo, hecto, deca, deci, centi, milli. So notice kilo has a lowercase k, hecto is a lowercase h, deca is a lowercase d and a, so D-A. Deci is a lowercase d, centi is a c, milli is a lowercase m. Okay. And here are some examples of how we write them. So here's an example: 100 kilograms, 342 hectograms, 98.2 centimeters, 490 centimeters, 1,890.2 deciliters, 8,998,432 kiloliters. Okay, so these are just examples of how we can write these out. And we're going to practice these all in these check your understandings. Okay. So check your understanding number 1. So we're going to write the abbreviations for the following written measurements. Okay. So you can pause the video here and you can try this on your own. And then once you're done and you want to, check the answers, come on back, play the video, and you'll check out the answers. So pause it and try it out yourself. Okay. So you paused it. So real quick, this is pretty simple. So centimeters. So remember we've got the prefix centi, and then we've got the. And actually, I'm gonna do that not in. I'm gonna do that in green, and then I'm going to do this in red. So we've got centi and then meters. Okay. So prefix centi, meters. Okay. So I remember that centimeters. Centi begins with a C. Meters begins with an M. So it should be cm. This guy's just liters, so it's an uppercase L. Decagrams, so we've got deca and then grams. So deca, remember, because it's deca versus deci, and trying to remember which one's which. Deca, because it has an A, we should just always remember it's DA. Deci, because there's no A, obviously it's just a D. So deca is we're gonna use the DA, and then it's grams, so it's DAG. And then grams all by itself is just a G. Meters is a lowercase m. Milliliters, milli is M. Liters is uppercase L. Decimeters, that's going to be lowercase d, lowercase m. And then hectograms, as an example, that's going to be H and then G. Okay. So if there's still something you don't understand, make sure you bring it to my attention. This is pretty simple. Like, all you got to do is go back to those previous slides to see what those abbreviations are, and we put them together. Okay? Because remember, prefixes are used like this. You have your prefix plus your root, and then plus, if there's a suffix, if there's ever a suffix or whatever you have to have at the end, then you have your suffix. So prefix, root, suffix. Okay? But in this case, with these numbers, with like centimeters, centi is our prefix, and then our root is meters. Okay. So centimeter. Oh, shoot. I did not mean to do that. Darn it. Here, I'm going to pull that back up. So I'm going to quick exit and pause it. So sorry about that. I need that little toolbar there. Nope, still don't have it. Okay, we're going to try this. Seriously, come on, man. Okay, let's keep trying this. There we go. Yikes. Sorry about that. Okay. So let's kind of keep continuing. All right, so check your understanding number 2. Okay, so last time we were the last check your understanding, it was the we were starting with the written form and we were making abbreviations. Now we're starting with abbreviations and we're going to the written form. So we got to go back, check our abbreviations, check what the prefixes, what the basic units are, to make sure we've got them right. So pause the video here, try this out yourself, and then come back and then see how well you do. Okay, so let's get into this. So we've got, for number 1, we got a D and a G. So if we look back, again, we know that our basic units here are grams. And then our prefix here, the D, should be deci. So decigrams, okay? So 100 decigrams. So number 2, we just have a lowercase g. So there's no prefix, so that means it's just grams. Okay. Number 3, we've got a K and an uppercase L. So the only K we have, I know looking at the notes, is kilo, and then the uppercase L is liters. Okay. Number 4, we've got a lowercase k, so again, that's going to be kilo. And then it's a lowercase g, so kilograms. Bada bing. Looks like we just have an m all by itself. Now, remember, because m for milli is a prefix, if you've got nothing to tag it to, then the prefix doesn't mean anything. So obviously an m by itself, it's not going to be milli. It's going to be meters. Okay. Any by itself is going to be the basic unit. It's going to be the whatever root unit, that you're referring to. Now here, though, in number 6 is the perfect example of the prefix plus the root, in this case, meters. So we've got the prefix m for milli, milli, 2 L's. And then the second m for meters. Number 7, we've got dA. And dA, is, we should know, is deca. And then we've got a G at the end. So we've got decagrams. And then lastly, for number 8, we have H, uppercase L. And the H we should know is hecto. And then the L is liters, hectoliters. Now these answers, for to check your understanding, they're also found in the speaker notes here. So if it's hard for you to read all this, they are also in the speaker notes. So keep that in mind as well. And again, if there's something you still don't understand, make sure you talk to me. Make sure you ask a question so you can better understand what's going on. All right, come on. And then the last one, I want to practice figuring out where decimal points are. So identify the location of the decimal point in these provided values. So simply just show me where it is. Tell me where it is. Draw where it is. So take a minute, pause the video, figure this out on your own, and then come back once you have those answers, and we'll see how they match up. Okay, so let's take a look here. So for 100, well, where is that pesky little decimal? So when there is no decimal, okay, when there's no decimal given to your value, the only logical thing, I can't stress this enough, the only logical thing that is a possibility here is that it's over here, that you have your decimal, that it's like this. It's 100 and then a decimal. That's where it's at, because remember, a decimal is not a whole number. A decimal is a fraction, okay? So if there is no decimal, that means you have a whole number, and that whole number has its decimal here at in this case, at the far right end, okay? I cannot stress that enough. It is not here. It is not here. This is not where it's at. Never will it ever be there. If it's not provided, it'll be here. Okay? If the decimal is not provided, it will be at the right hand end of your value. Okay? Again, I cannot stress that enough. Okay, for number 2, it's pretty clear. It's between the 2 and the 9. There's our decimal. Boom. Number 3, it's between the 7 and the 1. Again, almost kind of silly how easy this is. For number 4, it's going to be between these 2 zeros. For number 5, it's at the end of our 321. It's going to be right there. For number 6, it's going to be right after the 1. For number 7, it's going to be between the 8 and the 2. And then for number 8, it's going to be all the way over here after the 6 and 4,004,876. Okay. Now, again, I know this seems silly. I know it seems silly that we've got to look up and know exactly where the decimal is. Okay. You may think that's silly, but once we get into conversions in just a little bit, when it comes to the ladder method, we have to know where those decimal points are at, because we're going to be moving them. Okay. So we got to know where they're at. So we're going to continue. If you also still have questions, make sure you ask me. Okay. We're going to keep going with it. So the ladder method, So all those check your understandings are working up to understanding the ladder method. So, or maybe you've heard it as the bunny hop method, or I'm sure there's other words, names for it, but it's more or less a system to help individuals convert one metric prefix to another by moving the decimal point in a particular direction and a specific number of times. Okay. And as an example, it'd be saying if we were converting kilometers to meters, it would be moving that decimal point right here. It'd be moving this decimal point specifically three places to the right to then get this number, because they're the same thing. 109.4 kilometers is the same as 109,400 meters. These are the two same numbers. It's just that kilo has a range of 1,000, but meters has a range of 1. Okay, so this is a ones value, this is a thousands value. Okay, and I think the next slide should be these steps. Oh, and then there's that. Yeah, other examples. Oh, okay, so everyone will have this. You should have this filled out by now. So you will have this available for you on the quiz. That's going to be this Friday for A days, Monday for B dayers, but it's not going to be on the test. Part of the test is knowing how to put these together, in what order. I'll give you the values, but I won't give you the prefixes. So we've got to know the prefixes, okay? So this is like the more or less the ladder, if you want to see, because it looks like a ladder. You've got your what is it, struts? I forgot what those are called, but and then here dividing everything, you have your rungs. Okay, so it looks like a ladder, and we're going to hop all across, and we're going to see how that looks here in just a bit. Okay, I almost hit that X again. Okay, so how do we use the ladder method? Well, first we have to establish our starting units. After that, we're going to find our ending units. Okay, establish our starting units, find our ending units, and then we're going to count the number of jumps from the starting units to the end units. So how many other prefixes do we have to jump past to get to go from our starting units to our end units? We have to know the direction that we're jumping. We then find the decimal on the given value, and then move the decimal the number of jumps and the direction of jumps from steps 3 and 4. And then at the very end, we change the units to the ending units. So let's give this a try. Okay. And here, I'm going to transfer this guy to the 2 slides before. So 100 kilograms to grams. Okay. So let's take a look at that. So we're going to go back. So 100 kilograms. So 100 kilograms. We're going to use this guy. So 100 kilograms. We're going to go 100 kilograms to grams. So step 1, we're going to establish our starting unit. So here is where we're starting. We're starting here, and then we're ending. So that's our start, and then we're ending here. So that's our start. This is our end. Okay. So we've got to count the number of hops from here to here. Okay. So if we're starting here, we're going to go 1, 2, 3. So there's 1, 2, 3 jumps. Okay. Okay, so we've counted the jumps. Now we got to know what direction we went. So we went 1, 2, 3 to the right. Okay, we went 1, 2, 3 to the right. So how do we then use that? Well, we then put it together like this. We then, because we know we went 3 jumps to the right, we're going to take that 100, and we're going to take that 100 down here. We're going to take that 100 kilograms, and we're going to do this. We're going to find the decimal point, which is right there. And now we're going to do the same thing. We are going to jump 3 jumps to the right. So we're going to go 1, 2, 3. And that's where our new decimal place is going to go. Now, in these jumps, that's where we're going to fill in those with zeros. There's our new decimal point right there. And we're going to rewrite that. So it's going to be 100,000. That's our new number. And then finally, we have to now put in our new units. Our new units are grams. So that's how we use this method right here. This is why it's called, the ladder method. It's why it's called the bunny hop method, however you call it. This is how we use it. Okay, so let's try that with the other. Come on. Now let's try that without, you can use yours on your notes, of course. I'm now just going to write here just the answers already to go for you. Again, these are found for you in the speaker notes. Okay. And if there's something you still don't understand, you got to get a hold of me. Okay. So I'm going to find out where my decimal point is. It's right there. So meters to kilometers. So I know that from meters to kilometers, it's 3 jumps to the left. So it's going to be 1, 2, 3. So my new value is going to be 2.024 kilometers. Okay. And then number 3, kilometers to deciliters. So I know that the jump is going to be 3 to my basic units and then just 1 to deci. So I'm going to go 1, and I'm going to establish where my decimal place is, which is right here. And I'm going to be moving 4 jumps to the right. So 1, 2, 3, 4. The 0 goes there. So then my new number is going to be 980 deciliters. Okay. I'll put this guy over here. Okay, so grams to hectograms. So again, use your ladder, establish where your decimal place is, which is going to be right here. And we're going grams to hectograms. So I know that I've got to move my decimal place 2 places to the left. So I'm going to take my decimal, I'm going to go 1, 2. And what I should have is a value of 3,000, that's a comma, 3,000 hectograms. Okay, 3,000 hectograms. Okay, number 5, so millimeters to decimeters. So I know starting at millimeters, it's all the way to the right, and I've got to go to decimeters, which is 2 places to the left. So I'm going to find my decimal, and I'm going to jump 1, 2 places to the left. So my new number is 0.0, let's see, 0, 0, let's see, sorry, 0.00004 decimeters. Okay. Now, I know that seems weird because that's quite a few zeros, but that is how many we have to have here. Okay. And then the last one, 13,002 deciliters to deciliters. First thing we're going to do, establish our decimal point. Okay, right there. And I know that starting in deciliters, I've got to move 2 places to the right. Okay, 2 places to the right to get to deciliters. So I'm going to take my decimal, I'm going to move 1, 2, fill in that little jump with, or both jumps with zeros. And then my new number is going to be 13,000, or sorry, not 13,000. Be 13, but then 002, and then 00, and then we can put our commas in after, put in our end units, and then we've got 1,003 or 1,300,200 deciliters. So again, if there's any questions you still have on this, make sure you ask me because we went through this pretty quick and we got to know this. And then that should be it. So again, if you have any questions for me, guys, make sure that you ask me. That's the end of this lesson. I hope we are at a better understanding of how to use the ladder method, how to identify particular metrics units and SI units. And we're going to keep practicing this, and we'll have a quiz on Friday and Monday, respectively. So subscribe if you want to be notified when I upload videos so you can maybe get a head start. Or just know that I have new videos up, whatever the case may be. If not, then I'll just see you in the next one.